So the local arena has 10 applicants interested in working in a snack bar. In how many ways can 4 be chosen? Well, since we're doing combinations, you automatically think about combinations because this is the section that we're taking in the textbook. But on an exam, you're going to get all your permutations and combination questions are going to be mixed together. So you have to figure out, how am I going to know that this is a combinations question instead of a permutations question? How do I decide that? Well, the first question you have to ask is, does the order matter or not? If I'm hiring 4 people, does it matter the order that I hire them in? Or am I still going to hire the same 4 people if like, nope, I'm not going to hire you guys, I'm going to hire you guys. Wait a minute, that's the same. Just because I said it in a different order doesn't make it any different. So as soon as you decide, hey, the order doesn't matter here, it's going to tell you it's a combinations question. So we're going to have 10. We need to choose 4 of them. Order doesn't matter. We can go to our calculator, type this in, 10. Choose 4, not 1, choose 4. 210 ways. But you looked at all 10 applicants, and you know what? You said in part B, I think we're going to need to hire more people. We've got some more jobs that we need done. 4 is not going to be enough. We're going to hire 2 more people. Well, now, how many ways can we do that? 10, choose 6. Go to our calculator again. 10, math, over to choose, and 6. And what do you notice? It's the same thing. Why is it the same thing? Well, if you think about the formula, right? That's 10 factorial and 4 factorial, and then this would be 6 factorial because it would need to add up. And this one's going to be 10 factorial over 6 factorial, 4 factorial. You can see from the formula that they end up being the same. And if we think about it, so here I've got 10 different cards. Some of them are the same number, but with the suits that are different. Does it make sense if the order doesn't matter? In card games, the order often doesn't matter. If I choose, every time I choose a group of 4, I also make a group of 6. If I make a new group of 4, I make a new group of 6. So counting groups of 4 without order from 10 is the same as counting groups of 6 without order from 10. And so you can expand this even further. If I take all 52 cards, how many ways can I make groups of 51? How many different groups of 51 are possible? Sounds like there should be a lot, right? But the order doesn't matter. This group of 51 is the same as this group of 51, same as that group of 51. How many ways can I make groups of 51 from 52 cards? Well, let's ask the opposite question. If I have 52 cards, how many groups of 1 can you make? 52. There's 52 different single cards I could pick, right? And every time I pick a single card, I leave myself with 51 left. So 52 choose 1 is 52, and 52 choose 51 is 52 as well. Okay, so I'm going to give you some time to work on a couple of these.